Hello everyone. In this video, we are going to see dynamic analysis using Abaqus. So we are going to solve bending of 3D beam problem. In last video, we saw static analysis about this problem where monkey is sitting on a beam and how this beam will deflect because of the weight of the monkey. Now we are going to assume the monkey jumps from the beam. Because of monkey's weight, beam will be deflected like this. And when monkey jumps from the beam, it will come back to its original position, but because of inertia, it will not stay here. It will go further away and it will start oscillating. So in dynamic analysis, we are going to see how this beam oscillates after monkey jumps. So again, these are our material properties. For dynamic analysis, we will need a density as well. This much is the pressure we are going to assume monkey is applying on the beam, and we are going to stick with these SI units. Let's start. So always first thing, set working directory for Abaqus. First, let's start with the creating beam. I'm going to name this part as beam 3D deformable, approximate size 2. First, we will create a rectangle. Have to enter coordinate over here 0, 0. Say done, and the length of the bar is 1 meter. Now we are going to do partition on this top face. Where monkey is sitting. So we are going to fix this end and apply pressure over here. Let's go to property, create a material. First, we have to give Young's modulus and Poisson's ratio. Now for dynamic analysis, we have to define density. So I'm assuming density of wood is 700 kg per meter cube. Create a section. Assign the section to the beam. Next thing, assembly. Create instance. Now first, when monkey sits on a beam, beam is going to deflect downwards, and that will be a static analysis. So first we will create a static step. You don't have to change anything over here in static step, just say okay. Now for dynamic part. So when monkey jumps off the beam will oscillate. For that we need dynamic implicit step. So I'm going to name this as dynamic. Now over here, the bar is very stiff. So it will oscillate very fast. So we have to reduce this time period. I'm going to do 0.02. And to get uniform movement, I'm going to fix this time increment. So increment size 0.001. Keep this as 1000 and time period 0.02. So again, you can rotate by pressing Ctrl plus Alter. We are going to fix one side. Fixed end. And then first, we are going to apply pressure in static step, which is the first step. And magnitude is 30,000. So now bar is fixed over here. Monkey is sitting, so pressure is applied. And what we want to do is to replicate monkey jumping off. Just go in this load manager, and in dynamic step, you can deactivate this load. So now in static step, monkey is sitting on a beam. And when we go to dynamic step, it's like monkey jumped off because there is no pressure. Next is mesh. We have to do meshing on the part. So select part over here. Green means good. Structured mesh. Just check element type. 3D stress elements, standard, linear. Perfect. Okay. So seed the part. I'm going to go with 0.02 and this is mesh the part. Yes. Now go to job, create new job, dynamic analysis. Don't have to change anything. Say OK and submit it. So you can see over here static analysis is completed quickly, but now dynamic analysis will take time. We have total 200 increments. So let me just fast forward here. Okay, analysis is completed now. Let's go to results. Let me just make some more space over here. So this is the initial position of beam. And when we go to static step, so over here you can see which is the active step. So when we go to static step, we can see the beam is bended because of weight of monkey. And now as we go into dynamic step, now we are in dynamic step. Now monkey has jumped off. So bar will start to come up to its original position. And then it will not stay at original position. It will go up. And again, it will come back. So you can actually animate this time history using this button. So you can see how bar is oscillating. In reality, bar will stop oscillating after some time because of damping. But in this case, we don't have any damping, so it will just keep oscillating forever. And in the next video, we will include damping as well to make it more realistic. And contours are showing stress plot.
If you like this video, please show your support by subscribing to this channel, which will give me motivation to create more educational videos like these. You can also go to channel's playlist tab, and here you can see all the videos with similar topics combined together. For example, let's say if you're interested in ANSYS tutorials, you can go to this ANSYS tutorial playlist and see all the videos from this playlist. All the codes and files which I use for these videos are also available for you to directly download from this channel's GitHub profile. The link of this profile is given in the description box below. If you have any questions, please let me know in the comment section below. And as always, thank you for watching.